This could be a very long video. I'm going to go through all of problem 24 here in section 4.1. And notice there are 5 parts here. But this is a good example of running through a problem for this section. It covers a lot of stuff. If it is too long, I may have to divide this video up into 2 parts, as YouTube does have a time requirement that I'm allowed. So let us go and do this, and I'm going to approach this from a calculator standpoint. That's the purpose of these videos, since Course Compass does seem to not have a great way of demonstrating calculator stuff. So, having said all that, let's get down to business. Here's the problem. Population in a country that is born as da-da-da-da-da. What they want you to do is take this, and this is for part A, and they want you to turn it into a scatter plot, which is one of these two. Notice this mysterious number down here, and I'll talk about that in a second, and X scale and Y scale. So first of all, let's go through the pain of entering this data into the calculator, and you're going to do this just like you did in coming up with a regression line, which I did a video on earlier in the quarter. I go to Stat, and here's Edit, and I hit Enter, and I've got junk in L1 and L2. I go up to L2, the top of L2, and here's the junk. And do not hit delete. That will mess things up and you'll have to reset your calculator. But if you hit clear and enter, wipes out the whole list. Over to L1, clear, and enter. And now I'm set, and I can put this table into L1. This is going to be my X coordinate. L2, my Y coordinate. Look at this right here, this key statement here. The correct scatter plot of the data, choosing X representing the number of years since 1900. Okay, years since 1900. That means they don't want us to put in 1910, 1920, 1930. And this is always going to be the case with time. It could be years, it could be decades, it could be seconds, it could be months. But time is, you're never going to put the year in. It's always going to be the year from something, or the minute from something. So 1900, our first X coordinate is going to be 10. And let's mosey on down, put 20. Hopefully I can do the mental addition and subtraction here. So it's 30, 40, 50, okay. And then I get a complicated one, at least for me. 30, 40, 50. So I'm down to here now, and then 59. 308. Excuse me, 59, 69. Notice the professional way I do these videos. That was a joke. Probably not a very funny one. Hopefully I got everything here. Let me do a double check. I've got 10, 20, 30, 40, 50, 59, 69, 78, 87, and 97. Alright, over here, 144, 154, 162, 80, 221, 308, 395, 454, 467, and 492. That's what I'm talking about. Notice that there's these slash marks underneath this here, and the numbers finished off at the same exact spot, which means I didn't make any obvious typing errors. Now, I could have typed in the wrong thing, and since I want this to be a very precise video, let me make sure here. Otherwise it'll mess everything up and I'll have to reshoot it. Alright, we're good. I think we're good. Now we can go look at these mysterious numbers right here. 0120, 0600. X scale 10, Y scale 100. What they're talking about right here, and now we want to look at this thing. And to do that, I need to go to the where is window? Drew a blank there. So I push the window button. Notice I have X min, X max, Y scale, Y min, Y max, and Y scale. That's what all this stuff is here. So here it is X 0 to 120. X min is 0, 120, and they want the X scale to be 10 for some mysterious reason. They want 0 to 600, and the Y scale to be 100. Alright, I'm getting close here, getting real close. And we want to look at, so that's all I need to change here. Now we want to look at this thing. Go over to Y equals, and here is a key thing. Use the up arrow and hit enter. And that turns the plot on, so we can look at this beast. As soon as it's darkened, it's on, and I can look at it. So I move the arrow up, I hit enter, that turns it off. So let's go back, turn it on. You can see it's darkened, so that means we can go look at this. So if I push this graph button, whoa, there it is. Awesome. And that means that it's not A here. If I compare the graphs to what I have here in my window, it's B. And I check answer. Well done. Yeah, let's get the calculator. And we're ready to move on to the next piece. And my calculator will probably vanish again here. And I've already gotten close to 10 minutes, so it's looking grim here that I'm going to finish this in one video. Okay, here we go. Use the regression feature of a graphing calculator to fit linear, quadratic, and cubic functions to the data. Compare the values of R squared to determine the function that best fits the data. Okay, do you have R squared on? You probably don't, or maybe you do. In any case, I'm going to look and see. I'm just going to turn mine on. Now you would have, if we'd have gone and done a stat, and let's see if it's on. Let's do that first. They've asked whether it's linear or not. So let's see if it's linear. And to do that, I go to stat, go to test, and this is what we did earlier in the quarter. I ran a video on this, and I'm looking for, and I'm in the wrong spot here. Sorry about that. linreg. Enter. enter. I don't have an r squared here, so I need to turn this thing on. This gave me a nice little A and B, but I don't know how accurate it is, which is what they're talking about with this r squared. So let's go to second catalog, and you're going to look for this thing called Diagnosticon. So I hit enter again. Now x squared or r squared will be there. So let's go look at it. Stat, calc, and let's motor on down to linreg, which is right here, and enter again. And there is r squared. R you don't have to be too concerned about. They're more concerned about r squared, and there's a reason for that, but I'm just going to go through the rule here of why, or how you know it's a good r squared. The more worser, how about that one? The more worser a r squared is, the closer it is to 0. The better it is the closer it is to 1.0. 0.93 really isn't that bad of a fit, and I'll show you this in just a minute as how to actually take a look at this. But r squared is 0.93, so that's a pretty good fit. So what they're asking for right here is they want you to go through, do a linreg, quadratic, cubic functions, linear, quadratic, and cubic, and figure out which one of these is the most accurate. So you have to keep track of this 0.93. But let's go look at this, and I'm going to end up having to stop this video in just a minute because I'm at 11 minutes right now, and then I will continue on. But let's show how you can look at this thing. Alright, here we go. linreg. So stat, calc. Now in the past you have hit enter twice. Here you're only going to hit it once. Then you're going to go to this thing called vars, and you may have to repeat this video a couple times, but in any case, here we go. And you go to yvars, and you hit enter, and we want it to go into y1 so we don't have to retype this junk into it, and enter. Now you will see that this A 4.717 and B 42.2, you would have had to type that into y equals, but now lo and behold, it's there. And if you look at this graph, there's the fit for the line that's in the graph. So at this point I'm going to stop this video, and I will continue a part B in just a moment, and it will be in the announcement, so don't stress. And actually this may be a time for you to go do your intermission type things, so go get popcorn and soft drinks, maybe some M&Ms. And this concludes this video for a couple minutes.